Hello everybody, welcome to this video where I use Excel to solve the furniture linear programming problem. We went over the formulation a while ago, and the formulation for the furniture problem is right here. So the objective is to maximize 7 times t plus 5 times c, which is uh, um, um, the total profit. You get $7 of profit for every table, $5 of profit for every chair, and then you have the carpentry constraint and the painting constraint. And using this, we want to figure out what the optimal number of tables and what the optimal number of chairs are. And this time will be this video will be doing that using Excel, right? So there are multiple steps in doing that. The first step will be taking the data and inputting the data in Excel in a nice format so that it scales well. So this is a simple problem where you have a couple of variables, a couple of constraints, but what if you had like 10 variables and like 15 constraints or something like that? You need to have a way of setting it up in Excel so that you minimize the amount of work that you have to do. And that's what we'll be looking at today. So we'll take the simple problem, we'll go over the solution, and you will notice that it will scale really well when you have more variables and more constraints, right? Okay, so step one is putting it in Excel. So I'm going to open this up. Now, to do this, we are going to use Excel tool called the Solver. Now, the Solver tool, it's in different places on a Mac and on a Windows. If you it's not readily available, it is something called an add-in. For you to be able to get the add-in, you have to do a couple of clicks, go to a certain place and whatnot. It's not a difficult procedure at all. But what I will do is I'll post a video on Canvas which shows you exactly how to input Solver into your Windows computer. I will show you how to do it on a Mac. On a Windows computer, you can figure it out. Now, even on a Mac, the version of Excel I have is version 16.45. So the 0.45 doesn't matter as long as you're version 16 point something. It'll work. So this is the latest version of Excel for Mac. If you don't have the latest version for Excel for Mac, you can download it. You can go to Office 365 and download it. And this is one of the things that you have to be very careful about. You have to download and install Excel on your computer. You cannot use the online version of Excel for any of the stuff that we do for at least, I would say, the first 70% of the semester. Afterwards, there's something that we might do for the first 90% of the semester. In fact, you have to have an add-in called Solver. And add-ins are not available in the online version of Excel. They're only available in the downloaded and installed version of Excel, which means you need to have either a Windows computer or a Mac computer. You cannot have any other kind of computer, okay? It has to be a Windows computer or a Mac computer. You cannot do this on an iPad. You cannot do this on a Chromebook. You won't be able to go through this course with an iPad or a Chromebook. You need either a Mac computer or a Windows computer. It could be a laptop, it could be a desktop, that doesn't matter, but it has to have either Windows installed on it or Mac, or it's a Mac so that you have the Mac operating system, the OS 11 operating system. Now, I'm going to show you how to do it on a Mac. I will put up a video that shows you how to get Solver on Windows, but the way you set it up, the way you put everything into Solver is exactly the same. The only difference is where Solver is within the software. So Excel is a software. Within the software, Solver is in a couple of different places based upon which operating system you use. So for Mac, what you can do is if you go to Data, if you already have Solver, it will show up here. So right there, you see Solver. It will show up right there. If you don't have Solver, what you do is you go to Tools, and you go to Excel Add-ins, and then make sure that you check. You cannot just double click on it. You have to check the box and then click OK. So there is something called the Analysis Tool Pack. We don't need the Analysis Tool Pack just yet. We might need it later on in the semester, but if we need it, I'll let you know. But the Solver add-in is the one that we'll be using extensively through this course. So make sure that you check that box. And I'm going to click OK. All right. So you need to have the solver. You cannot solve problems on Excel without the solver, right? So that's step one. After you have the solver, the next step is to put the data in it. I'm going to increase the font size so everything is clear on the screen. What we're going to do is the way we usually set up linear programming problems in Excel is we use rows for writing constraints and objective functions and whatnot, and each column is going to represent a different variable. In this case, we have two variables, tables and chairs, T and C, right? So this column I'm going to call tables. This column I'm going to call chairs. Now, why didn't I start with the first column? Because I want to write some names and give some context for what we have here. That's the only reason. So this is the column. So all the coefficients, the final values for how many tables to make, how many chairs, they're all going to show up within these columns corresponding to tables and chairs, right? So very first thing is the decision variables. These two cells here, so not B1 and C1, but B2 and C2, these two cells here, right here, I'm gonna color them. I like coloring my decision variables. So these two cells here are going to represent the number of tables and number of chairs. So when you look at the problem formulation, you have the variable T and you have the variable C. Till you actually solve the problem and find the value of T and C, you don't know what they are. They're variables, and those variables will be represented by these two cells. This is the variable T and this is the variable C, not these two cells, but these two cells here. So once you solve the problem, these cells are going to get populated with some numbers. Otherwise, till then, the cells are going to be empty, right? So that's first decision variables. Now, apart from this, we're also going to write constraints. Now, constraints, every constraint has a left-hand side for the constraint and a right-hand side for the constraint. So I'm going to call them left-hand side and right-hand side. You can also call it the formula and the constraint. That's what the solver calls it. Either way, I'm going to call it the left-hand side and the right-hand side. I'm just going to say left-hand side here. So this is where all the left-hand sides of the constraints will go, and this is the right-hand side for the constraint. Right? You'll see more about this in a second. Next is the objective function. Now, step one is just inputting data, right? So the objective function is 7 times T plus 5 times C. So you want to maximize 7 times T plus 5 times C. So let's leave maximize alone for the time being. Let's just input the data. So 7 times T plus 5 times C. So it's 7 times, so 7 under the table. So coefficient for the objective function, 7 for tables and 5 for chairs, right? 7 times T, 5 times C. So those are the coefficients. So I'm going to leave that there. Next is the constraint. So first we have the carpentry constraint. So again, I like giving names to my objective function constraints and whatnot. This is completely for flavor. It doesn't add anything to the problem at all. You can have an empty column here, it doesn't matter, right? So I just like knowing what I'm writing, so I write down names for it, but writing names is not really that important, especially when you have, let's say, 15 constraints or 20 constraints or something. Writing names for each constraint might be, a little bit much. Okay, so let's try the carpentry constraint. So the carpentry constraint is 3 times T plus 4 times C is less than or equal to 2400. So like I said, right now we're just inputting the data. So it's 3 times T plus 4 times C is less than or equal to 2400. You'll notice that I made this column really small because this is where I'm going to write the less thans and the greater thans. Again, this is only for our for my edification. This is not going to go into the solution directly. It's just to know that this is a less than or equal to constraint for me right now. Next is the painting constraint. The painting constraint is 2 times T plus 1 times C, right? So, oops, sorry about that. It's 2 times T plus C. C is just 1 times C. That's not 0 times C. It's 1 times C, okay? Just keep that in mind. 2 times C plus 1 times C is less than or equal to 1000. That's the second constraint. The first constraint is 3 times T plus 4 times C. So there you go. So right now all we've done is input the coefficients. We still haven't told Excel that, So Excel is just a tool. So Excel can't guess that our objective function is 7t plus 5c. We have to explicitly say that. And that is where the left-hand sides of the constraints are going to be important. Once you input all the data here, once you input all the coefficients for all the decision variable, the objective function and the constraints, we can put that into we can put those formulas here into the left-hand side of the constraint. And that's what we're going to do. Right? So let's begin with the objective function. So the objective function is 7t plus 5c. So the simplest way of writing that would be, say, 7 times t plus 5 times c. Because remember, this is t and this is c. So 7 times t plus 5 times c, that's the left-hand side of the constraint. Straightforward, simple, right? But what this does is you have to go click, 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 click every time you have a coefficient or a variable, And what if you had, let's say, 10 decision variables, and you have to do click, click, click for the objective function, and then you have to do it again for each of the constraints. So it takes a lot of time. Is there some way to make this easier? Yes, there is. First thing to notice is that because the variables are here, every time we write, let's say we write the left-hand side of the carpentry constraint, it will be 3 times t plus 4 times c. So you'll always be referring to this cell and always be referring to this cell because this is where the variables are. But the coefficients are going to change. So next time we write this constraint, it will be 2 times t plus 1 times c. So maybe b and c, so these two cells, the B2 and the C2 that we have here, they should be absolute references. They should be with the dollar signs so that every time we write the constraint, you're just referring to the same thing. That's one thing. And the other thing to notice is that there's a much simpler formula in Excel which lets us do this. And the reason why it is good to use that formula is it scales well. So it doesn't matter if you have 2 variables or 10 variables, you're just still going to write a single formula. And that formula is based upon what we are doing here. So what we're doing here is we're multiplying these two numbers. We're multiplying these two numbers. So we're multiplying the numbers together and then adding them up together. So we are finding the product. So in terms of mathematical nomenclature, multiplying is called product, right? So you're finding the product of these two numbers, you're finding the product of these two numbers, and then you're summing them together. So there is a function in Excel called the sum product function, which does exactly that. And it's a much easier function to use. Again, like I said, when you have more decision variables, you have lot more decision variables, it scales really well. So sum product function, the way it works is you choose either a row or column, then you type in a comma. Don't forget to type in the comma. Typing in the comma is extremely important. You type in a comma and then you choose again another row or column. Now, if you're choosing two rows, both of them have to be rows or both of them have to be columns. One can't be row and the other be column. You can't have that. So, and the size of the row and the size of the column has to be the same. Now, you can also choose a 2 by 2 set of row and column and a set of row and column. You could do that too, but we'll not be using that right now. Don't worry about that. So what this does is, when you write this formula, it's going to multiply this coefficient with this variable. It's going to multiply this coefficient with this variable. It's going to add them together. Coefficient variable, add them together, right? So that's the objective function. Now, similarly, we can write a sum product function for the carpentry constraint. We can write a sum product function for the painting constraint. But like I said before, because we are always going to refer to T and C as the variables T and C right here, what I'm going to do is I'm going to make the variables, the decision variables, a absolute reference. So the decision variables are going to be an absolute reference and the coefficients are going to be relative references. So this way, the importance of writing it this way is that once I write the formula this way, I can copy the formula down. And then I'm done. So this way, I just have to write one formula and then just copy the formula all the way down. I don't have to repeat the formulas again. Okay. Why? Because when I look at this formula now, you'll notice that it is 3 times t plus 4 times c. These two, this part of the object of the sum product formula doesn't change. It's only the coefficients that changes, and that is exactly what we want, right? So this is the second step. First step was just input the data. So that's all we were doing. We just input the data to all the cells, the right-hand sides of the constraint, the coefficients for the objective function, the constraints, and all of that. The second step is writing the formula. So again, if you did everything correctly and you set everything up well, you just need to write one formula and then just copy the formula all the way down. So that's the formula. And then finally, let's put this into the solver. So that's the third step. So I'm going to go to step 3, but before I do that, so this is what you need to do, write the formula, right? Just writing the coefficients is not enough. You have to write the formula, because once you write the formula, this is our problem right here. I'm going to just do that for a second. So this is our problem. The coefficients don't matter anymore. This is the objective function. This is the left-hand side of the constraint. This is the right-hand side of the constraint. Left-hand side, right-hand side. All this typing in that we did is so that we are able to write the formulas in a very simple manner and not have to replicate our work again and again and again, right? Okay, now the other important thing to do is, in this case, we have only 2 constraints and both constraints have less than or equal to. But let's say in the next problem, when we do the simple minimization problem, for example, there you have 1 greater than or equal to constraint and 2 less than or equal to constraints. Sometimes you'll have less than or equal to constraints, equal to constraints, and greater than or equal to constraints. When you have that, to simplify your work later on, you'll see that in the solver. To simplify your work, write all the less than or equal to constraints first or together, then write all the equal to constraints and then the greater than or equal to constraints. The order doesn't matter. Just write all less than or equal to constraints together, all equal to constraints together, and all greater than or equal to constraints together. That way, when you put it into the solver, it will save a lot of time, right? Okay, let's finally use the solver. So I'm going to go to data. I'm going to go to data. So this is the same in Excel, in Windows on Excel. Once you add in the solver as an add-in, it'll be available within the data tab. You go to the data tab, click on solver, and you will see this. Now it will look exactly the same even in Windows, just the colors might be different, and I think it's slightly larger in Windows, but other than that, everything looks exactly the same. The first thing that I want you to do always is, you see that says GRG non-linear. What we are doing is linear programming. So you need to change that to simplex LP. LP stands for linear program, and simplex stands for the algorithm that Excel uses to solve the problem, right? So LP is what we're using. Don't forget to change that. Next, we know that our problem is a profit maximization problem. So make sure that you check maximize. Now maximize will be checked by default. If you're doing a cost minimization problem like the simple minimization problem, make sure that you click on minimum. Now this box should always be checked. This is the non-negativity constraint, saying that all variables are non-negative. Make sure that that box is checked. Now, once that is done, let's start putting it in. The first step is the objective. So I'm going to click here. So in Excel, you'll see a more colorful sort of box here. But anyway, so I'm going to click on it and then choose my objective. So this is where the formula for the objective is. You're not going to choose the 7 and 5. The 7 and 5 are done. Once you write the formula, the left-hand side of the objective, that is your objective function. Now, in Excel, it's going to say sheet 1 exclamation, because the name of the sheet is sheet 1. That is all that means. Just ignore it for the time being. It will go away in a couple of minutes. But D4, this is where my objective function is. So D4 is my objective function. I'm maximizing my objective. And the changing variable cells, these are the decision variables. So I'm going to click on that and choose my, in this case, just the 2 decision variables. So again, it says sheet 1, just ignore that for the time being. So B2 to C2, the B2 to C2, those are my 2 decision variables. And finally, let's add the constraints, right? So because both of the, so we have 2 constraints here, a couple of options. One is you can write the left-hand side for the constraint is less than or equal to the right-hand side for the constraint. Simple. And do that, and you can write each constraint individually. But what I like to do is I like to add all similar type of constraints at the same time. For example, both of these constraints are less than or equal to constraints. So I'm going to choose both the left-hand sides of the constraints at the same time on the left-hand side, and both the right-hand sides at the same time. Okay. What this does is, we'll say D6 to D7 is less than or equal to F6 to F7. So you're essentially saying D6 is less than F6, D7 is less than F7. So D6 is less than F6 and D7 is less than F7. That is where our constraints are. So this way, even if you have like, I don't know, 10 less than or equal to constraints, you can just write them all in a single constraint. You can just group them all together. That's why I said write all less than or equal to constraints together. That way you can group them all together and then you're done. Okay. So I have my objective. I'm saying that it's maximizing. I have my decision variables. I have all my constraints, even the non-negativity constraint. I changed this to simplex LP. All that's left to do is to click on solve. And that's exactly what I'm going to do. Click on solve. And there you go. So it says solver found a solution. All constraints and optimality conditions are satisfied, which is good. If you get an error here, you either wrote the formula incorrectly or something else is incorrect somewhere, and you can figure that out. Now, we will do sensitivity analysis, but I will post a different video for that. Okay, so let's look at the final solution. This is the same solution you'd get if you did, say, the graphical method, right? You get the same solution. So you're saying that your profit, maybe I'll color the profit value also. So you're saying that the profit is 4,040. And you get that by making 320 tables and 360 chairs. And this profit, this weekly profit that you're making of 4,040, this is the maximum you can do. You cannot do better than this. Any other solution that you pick will give you a worse profit. This is the optimal, this is the maximum value of profit that you can get. And you can get that by making 320 tables and 360 chairs. And that is the final solution to the furniture problem. All right? Okay, take care.